This goes really, really well for you. Here are some answers, some steps for these. So for number one, it's basically just one operation. It's addition and subtraction up there. So negative 5 plus 12 is 7. This is really plus a positive. 7 plus 9 is 16, minus 11. I got 5 for that one. What do you guys think? Good? Any questions? Did that all in one step. I'm hoping you guys are getting to that place where you can do that pretty, hopefully comfortably. Number two, clearly does not involve one operation, right? So we're not going to just go left to right. In math, we rarely read from left to right. Almost always read according to order of operations. You see there's a lot of work to be done in the parentheses there, so let's do that first. So it'd be 9 minus 5. And then in there, I've got 4 times 2, which is 8, minus the absolute value of negative 10 is 10. So notice that squared out there. I can't apply that squared to anything in there until I've simplified everything in the parentheses first. So I'm just going to leave that alone. There's just a little bit more work to be done in there. 8 minus 10 is negative 2. And we got this right here. The last thing I'm going to do here with those parentheses is that exponent, right? I've cleared all the parentheses work. Now I'm going to do the exponent. What is negative 2 if it's in the parentheses squared?
4.
It's positive 4, yeah. So it's going to be 9 minus 5 times 4 plus 6. I'm going to clear out my multiplication, which is right there in the middle. 5 times 4 is 20. So it's going to be 9 minus 20 plus 6. And I am down to just the single operation, just addition and subtraction. So I'm getting negative 11 plus 6, which is negative 5. Okay, so again, any questions, comments, thoughts, concerns at all? Anything? Okay, cool. Number 3, simplify completely. Negative 3, oh gosh, what about the negative 3 in the parentheses? What is that? It's distributive property, that's right. Do you guys see any other distributive properties up there? Yeah, the 8. The 8 gets distributed as well. So this would be negative 21. And this next symbol, I know I said this 1,000 times, I'm going to say it even more. That next symbol is the symbol that if somebody's going to mess this up, it's probably where it's going to be. The next symbol should be plus, right? Because a negative times a negative is a positive. So plus 3x. And then you also, as you guys said, distribute the 8. So it'd be plus 8x squared minus 8. Because a positive times a negative gives you a negative. And then from here on out, it's just a matter of adding like terms. Do you guys see any like terms up there?
21 and 8.
Yeah, the negative 21 and negative 8. Those are like terms for sure. So that gives me negative 29 when I add those up. But what about the 3x and the 8x squared? Those both have x's. Are those like terms? I could add those up and get like 11. No? Yeah, one of them is x squared, which is a different variable than x. And so those are unlike terms, so we cannot add those. Plus 3x plus 8x squared. Okay, so numbers 1, 2, 3, any questions? Hanging in? Okay, so let's do this last one here. This last one is much newer. We started doing these last week. So it says solve for x. So we're going to get the x by itself. We're going to find the solution, the number that makes this equation true. So we got to get the x by itself. What do you guys see as maybe the first thing we ought to do? Should I get rid of the 3 or the minus 11 first? Minus 11. We're always going to try to get rid of that addition first once we're simplified here, and we are. So it'd be plus 11. And make sure you make note that you're adding that 11 to both sides, not just one side, but both sides. All right, so then when I do that, I get 3x is equal to 13 plus 11 is 24. Finally, I got to get rid of the 3 that's attached to the x. How would I get rid of that? Right, because it's 3 times. The way I do that is I divide by 3. So dividing by 3 on both sides, I get x is equal to 8. That's my proposed solution. How could I check that if I was wanting to check to be for sure that that's right, Joe?
You could do 3 times 8, so just put the 8 in for the x.
Okay, yeah, put the 8 in for the x. 3 times 8 minus 11 equals 13. You get 24 minus 11 equals 13. And sure enough, 13 really does equal 13. Okay, so there's that. Any questions at all? Okay. I definitely want to give you plenty of chances. This last DMR quiz was definitely the lowest scoring of all the DMR quizzes we've done so far. Starting to get a little bit more challenging, perhaps. I don't know. I did notice a couple of order of ops mistakes and things that would definitely be worthy of cleaning up. So if you're okay with getting 1 out of 4 or 2 out of 4, which I personally would not be, I would just sit there in silence. But if there's any questions, maybe you got 3 out of 4 and just that one you missed, you're just like, I don't get this. You could ask about that. I don't know. Anything at all, whether you did really well, medium, maybe you got kind of lucky. Maybe you got 4 out of 4, but on one of them you sort of guessed, and you guessed the right way to do it, and you got it right. I don't know. Anything at all. Any comments, thoughts, concerns? No? Okay, fair enough. Well, we're going to move into our notes here in just a second. And we're going to look at these. These 3 examples right here. If you notice, as far as comparing this to the equations we've worked on before, these are pretty different. Like, what's missing? Numbers, right? For the most part, I guess number 3 has a few numbers in it. But numbers 1 and 2 have no numbers. And number 3 has a couple of variables, right? So it's a little bit different. So I wanted to take our time here and make sure that we go through these carefully and hopefully make sure you understand exactly what's happening and how we want to get where we want to go. So number 1 says solve for R. Can anybody remind our class what the words solve for or solve could be interpreted as? You could say solve really means, oh no. You're either really tired, so tired that your mouths don't work, or you don't remember. Raise your hand if you're so tired your mouth doesn't work. Yet you raised your hand somehow. Interesting. Okay. Anybody, come on now. This works better. I mean, if you really want me just to make a speech, I guess I can do that, but it works better if I talk a little bit and then you talk a little bit and it goes back and forth.
Is it find the sum?
Find the sum. So solve for, find the sum. Well, I would say that's a little too specific because not everything is a plus, right?
True.
There's minuses and there's times and there's divideds, and I think it's a little too specific. Go back and think. I said this last week, and I know it was last week, and so I think it's been a little while. Come on. Thank you, Noel. I appreciate you offering up an idea, for sure. Josh?
Find the solution.
Find the solution. Okay. That is pretty good. Find the solution. So in other words, this is actually pretty typical of what we did last week. Didn't we try to find a solution for an equation, and then didn't we check it by plugging back in? It's going to be kind of rough to find the solution here. The plugging back in is going to probably be more complicated than the solving of the equation. So I might think of this as a slightly different, although that's accurate, think of this slightly differently. Noel?
Find the number that makes it true.
Okay, and that's kind of what Josh is saying. Find the number, find the solution that makes it true. The only problem with number 1 is, where are the numbers? There are no numbers other than like it's 1p, 1r, minus 1c. I get that. But otherwise, there are no numbers anywhere. So that is true, Noel, but I don't think that's going to help us with this equation. There's another way to look at it. Ava?
Find what R is equal to.
Okay, now we're starting to tie it together. So if you're finding what R is equal to, in the end, what would it look like? What would that look like?
Use the letters like minus C plus C on the other side.
Okay, and so then the R, once we did all that stuff, the R would be what? Found, because it would be alone. There it is. The R would be by itself or alone. That's what I'm looking for. So for these, I think it's probably better to look at the word solve as this. So if it says solve for R, I think we should think of get the R by itself or get the R alone. Okay, so get the R all by itself on one side of the equation and all the other stuff on the other side of the equation. Does that make sense? You came up with it. It took you a little while, but you got there. That's great. Okay, so then let's see if we can attack this. And Ava kind of laid the foundation for us. The R clearly is not by itself, is it? We need to get it by itself. That's what the directions say. So it does have this R minus C with it. So how do you get rid of minus C? You add C, yeah. So you can't just add C to one side. You got to, whatever you do to one side of the equation, you have to do the same thing to the other side. So on the right side, what's negative C plus a positive C? 0, right? So they just add out completely. The C from the right side is gone. That was the whole point here. So the right side is just r, so that we've kind of attained our goal. But then we got to figure out the left side. What is p plus c? Is that,
No.
isn't it, could it be pc?
No, because that's multiplication.
Yeah, that's multiplication, and those are unlike terms. And so, yeah, you guys are right. So this would just be p plus c is equal to r, and that would be our solution, right? So p plus c would make this work. So technically, you could plug the p plus c back in for r, and you could see it work just fine, right? The c's would add out, and you get p equals p and all that. But I prefer to think of this as the get the r by itself kind of an operation. Okay, what do you guys think? This is different. So far, okay? Okay, so let's take a look at number 2. Number 2 says solve for t. I equals p times r times t. So here's the t right there. And solve for t means get the t by itself. There we go. But clearly the t is not by itself. There's a p, and there's an r over there with the t. How are the p and the r attached to the t?
Multiplication.
Yeah, it's p times r times t. So how do you want to do multiplication? So I'm going to divide both sides by pr. That'll get rid of this in one step. You could divide by p and then divide by r, or you could just divide by pr because it's the same thing. So the prs would cancel out. This would leave me with t equals I over PR. Just a little note on this. If you're doing a WebAssign with these types of questions, WebAssign is very, very picky even about uppercase, lowercase. So if that's a capital P or a capital I, let's say, and in WebAssign you put in a lowercase I and or a lowercase p, WebAssign will say wrong. You got to go with whatever it is. So if it's a capital, you got to leave it as a capital. I will not be nearly as picky. I'm going to see, hey, there's only one p in there, whether it's capital or lowercase. I'm not going to get too stressed about it. WebAssign will get very stressed. So just a hint there on WebAssign to hopefully reduce your stress a little bit. Okay, any questions on 2? Okay, so thinking about what's coming next, number 3 is probably the most important question of this group. And so number 3 says solve for y. And here it is. This one actually has a few numbers. Kind of cool. You got 3x plus 5y equals 20. So I want to get the y by itself. You can see pretty obviously the y is not by itself right now. What are the things that are with the y on that side? 3x and 5, right? So if I could get rid of the 3x and if I could get rid of the 5, mission accomplished, right? The y would be all by itself. What do you guys suggest? Should I get rid of that 3x first, or is it better to get rid of the 5 first? 3x. That's right. So any term. So I would say this right here, this 3x, is a whole extra term. It's just hanging out there on the front. We want to get that whole term over. We're not going to move the 3. We're not going to move the x. We're going to move the whole 3x. We're going to do it in one shot. How do you think I could move that 3x, the whole thing, over to this side? You have to subtract it over because right now it's positive 3x, right? So I'm going to subtract that 3x over to the right side. So on the left side, what's 3x plus a negative 3x?
20 minus 3. Oh.
What's this? What's that right there?
0.
0. They add out completely, right? You have 3x's and you take away 3x's, you got nothing, right? So those are going to add out completely. So I'm just left with positive 5y. What about the right side? What's 20 minus 3x? Is that 17x?
No,
Why not?
because the 20 doesn't have a variable.
So therefore, the 20 and the negative 3x are
Different.
not like terms, unlike terms. That's right. So 20 minus 3x is over there. Oops. So then my final step is going to be, how do I get rid of the 5? Division by 5. So you could do this one of two ways. This first way is 100% correct. I just divided both sides by 5. The whole side, right? The whole right side, the whole left side divided by 5. The 5s would cancel, giving me y equals 20 minus 3x over 5. So I think that moving forward, like I would give you full credit for that. That's a great answer, no problem. But I think moving forward, I think there's a better way to do this. And those of you that have graphed lines before, graphed linear equations, are going to maybe understand why. I think what I'm about to show you is a little bit better. Although what I just showed you is 100% correct, no problems. I think it's a little bit better for what we're going to do moving forward. I'm going to divide both sides by 5, but I'm going to write it like that. Okay, so this is going to be better moving forward. as we start to graph these linear equations. This would give me y equals, well, what's 20 divided by 5? That's kind of nice. That divided out really evenly. And then just minus 3/5 x. That one can't, of course, be divided nicely. So we would leave it like that. But I would give you credit for either one of those. Totally fine. Question?
So we could, for the second one, we could write that down too, like y equals 4 and then this.
Oh, yeah.
So
This-
we could write that as the answer?
Totally. So these two answers, these are 100% correct. They are equivalent. It's just the right side. You know how like when you add or subtract fractions, you have to have a common denominator and add? Basically, all I'm doing between those two is I'm splitting up the common denominator and adding thing and then reducing. So if you wanted to make them look the same, we could just get a common denominator between those two terms and then add them together. And you get the same thing either way. But I like this way better. As we start to graph these linear equations, that'll be more useful. I'll take either one, though. Yeah. Okay. Anybody else? Any questions? Thank you, Kyrie. Okay, awesome. So you guys got 3 to practice with, so please flip on over to that other page. You want to really practice hard, get after it, do your best with these. Oh, there, you know what? I'm sorry. There is a little typo here. Number 3. Do you see where number 3 says solve for t? I don't want you to solve for t. I want you to solve for v. So I'll change that up here. Change that in your notes. Please solve for v, not t. Okay, so have at it. You got people to work with, and I'll be around to help if you need it. Write some questions. Number 1, how many of you were like bugged by that 1/3? A little bit, right? It's like, 1/3. Why did there have to be a fraction? Think back to those properties that you made your posters on. And by the way, I'm about a third of the way done grading those, and I'll try to work on the rest of those today. In any case, think about this. How do you get rid of times 1/3?
Multiply by 3.
You got to multiply by the reciprocal, which is 3 in this case. So, yes, I'm going to multiply the right side times 3, and I'm going to multiply the left side times 3. If you want to put it as a over 1, just to get all the numerators and denominators to match up, that's totally fine. But in any case, wouldn't this 3 cancel with that 3?
Yeah.
That's the whole point. We're trying to balance this equation out, and the first step would be to get rid of this 1/3. So then on the left, 3 times a is just 3a. 1 times 1 is 1. I'll just leave it as 3a, because 3a divided by 1 is just 3a. So this now equals b times h, or 1 times b times h. And I'm down to just kind of my final step here. I want to get the h by itself. Clearly there's a b on that side with it. So how do I get rid of the b?
Divide by b.
Because it's b times, to get rid of that, you do divide. So dividing by b, I end up with 3a over b is equal to h. I did, walking around peeking over shoulders, I did see a slightly different answer, and I wanted to point this out. I saw some folks that started off with the same thing we all started off with, and their first step was to divide by 1/3 b. This is actually a correct step, isn't it? They're like, I'd like to get rid of the 1/3 times h, so they divided by 1/3. And they wanted to get rid of the b, so they divided by b. The 1/3 would cancel with the 1/3, the b would cancel with the b. The only issue is, when they got to this step, they left it like that. That is numerically correct, but it's not in simplified form. This is a copy.flop, isn't it?
Yeah.
Whenever you divide something by a fraction, you just go copy.flop. So this would really be a times 3, right? You'd flop the fraction. A times 3 over b, which is the exact same thing as that. So just caution you to make sure that you've got a good simplified form. All right, so let me just pause right here. Any questions on number 1? Okay. Number 2. I'm trying to get the w by itself. Anytime you've got an extra term hanging out there, like that 2l, I'm going to get rid of that first. So how would I get rid of positive 2l? I'm going to move the whole thing over by subtraction. So minus 2l. That's going to give me p minus 2l on the left side equals 2w on the right side. And doesn't it kind of feel like we're done? Bless you. It feels like maybe we're done, but we're not, because the w is not by itself, right? You see, what's with the w still? And remember, the goal of solving is to get that variable by itself. So is it 2 plus w, 2 times, 2 minus, 2 divided by w? What is it? Oh, you're not really listening. I'm asking, is 2w, is that 2 plus w, 2 times w? It's 2 times. So how do you get rid of 2 times? Divide by 2. So I'm going to divide the right side by 2, and I'm going to divide the whole left side by 2. This gives me P minus 2L over 2 equals W. And now the W is by itself, and so we followed the instructions. We've solved for W. Does that make sense? Any questions? Just give you a moment. Think it over. Okay. All right, and then finally, let's do number 3. Remember, 3 had a typo. We're going to solve for V. All right, so this one looked the most complicated, didn't it? Maybe you figured it out, that this really is not that different than number 2. It does have a number in there, and there's V's and T's and H's, but it's not that different from number 2. Any suggestions on a first step?
Plus 16t squared.
Does that make sense? We want to move this whole, bless you, we want to move this whole term over to get it away from the V, and it's minus 16t squared, so we need to add that to both sides. So I like that. I think that's a good idea. So we're going to go plus 16t squared plus 16t squared. This gives me h plus 16t squared equals vt. Now, so I'm down to the end here, right? Because the t, or the v, excuse me, is all by itself, almost. It just has that t there. Any suggestions on how I could get the v by itself? Divide by t. Are you with me?
No,
Somebody say no?
Yeah.
You are. Okay.
Not meant to.
All right. So the t's would cancel, leaving us with h plus 16t squared all over t is equal to v. And that form right there, it's the simplest form. That would be our solution. Okay, so please carefully look at what I have up there. Hopefully you've been keeping up with what I've been doing with numbers 1 and 2. I'd love to answer questions for you. If you don't have a question, you're welcome to get out some sort of electronic device. You guys have almost 15 minutes or so where you could do some WebAssign work. You could do some quiz retry practice, that sort of thing. I'll be around to help. Please let me know how I can help.